So today we'll learn about the test management. So whatever we have learned till until three chapters, actually in the fourth chapter there are the test design techniques, and after that this chapter comes, which is the test management. So whatever we have learned in the test management, we have to see like how we have to manage the things. For example, we can say the test planning techniques, we have the test levels. Now we have also learned about the static testing as well, and what is the role of each and every one, especially for the test leaders and test managers, how they gonna manage everything in very well way. So they have explained here in the detailed way, like the management process mainly. Okay, so hmm, uh, actually we have to learn about this risk and testing. So now it is not possible to talk about test management without first looking at risk and how it affects the fundamental test process defined in chapter 2. If there were no risk of adverse future events in software or hardware development, then there would be no need for testing. In other words, if defects did not exist, then neither would testing. So they are saying like, for example, if we are performing the testing and we are finding the defects. So if, for example, defects will not exist, and we just have to check the things and we just have to provide our confirmation like, yeah, things are working in perfect way. So there is no need of testing because we are not finding any kind of uh, fault in the system. So that's why we have made this testing process to find the errors or defects. Apart from that, we can say the happy flow. So everything should be worked as per the testing process. And they are saying it is very important to identify the risk. So in this chapter mainly we'll see like where risk will come, at what points we have to consider what percentage of risk, and how we gonna manage this in the future activities for that project. So risk can be identified as a chance of an event, hazard, threat, or situation occurring and its undesirable consequences. So just remember this, what is risk in terms of ISTQB. You have to learn this line like a factor that could result in future negative consequences, usually expressed as impact and likelihood. So they are saying risk is a factor that could result in future negative consequences, usually expressed as impact and livelihood. So we all know what the risk is actually in our terms, but for ISTQB, you have to remember this kind of line because you will get straightforward this kind of words, and you have to understand, you have to choose the perfect option. So you'll get the question like that, what is the risk in test management process, or you will get what is the risk, simple question, and you'll get four options. All the four options will look like correct, but in terms of ISTQB you have to choose the correct option, which is risk is a factor that could result in future negative consequences, usually expressed as impact and likelihood. So they are just saying like it's a kind of future negative consequences. In the future, what could be the negative situations can come. Usually we will be defining the impact and what is the likelihood of that uh, impact. So it it is risk. And also here they are defining like risk can be defined as the chance of an event, hazard, threat, or situation occurring and its undesirable consequences. So you will get maybe this kind of option or maybe this kind of option. So you have to choose it accordingly. So risk can be a hazard, threat, or situation or event as well. and its undesirable consequences, or you will get this kind of option like risk is a factor that could result in future negative consequences. Now, in a project, test leader will use risk in two different ways: project risk and product risk. In both instances, the calculation of risk will be level of risk is equals to probability of the risk occurring into impact if it did happen. So they have just provided the definition in terms of test leader, like how test leader should calculate this risk in terms of project risk or product risk. So in both instances, he is following this formula like level of risk is equals to probability of the risk occurring. For example, how much is the probability of that particular risk to occur into impact if it did happen. So it's like they are calculating with this formula: level of risk is equals to probability into impact. So you have to remember this: probability into impact. So in this way, you will be able to choose the correct option, like probability of the risk occurring into impact if it did happen. So this is the level of risk. Now they are explaining what is project risk and what is product risk. Okay. So project risk include supplier issues, failure of a third party to deliver on time or at all, contractual issues such as meeting acceptance criteria. So what can be the risk in the project when we are defining or starting any project? So, or in between, maybe we'll get some kind of issues. So they are explaining it like there may be supplier issues. So what kind of supplier issues? Like failure of a third party to deliver on time or at all. So for example, we have a dependency to deliver something from the third party, and it is not delivered on time, and we are just blocked because of this. So it's a kind of supplier issues, because they have to supply, but we are just blocked and they have not supplied it on time. Now contractual issues such as meeting acceptance criteria. So it's like whenever they are making the contracts, or maybe meeting acceptance criteria is not matching. They have defined a particular acceptance criteria, but when we are conducting the meetings and we are not actually focusing on what is the acceptance criteria of that meeting, rather than we are just discussing our own way. So this is also a kind of supplier issues. Now where we can see this organizational factors. So organization factor is related to just with the man force, for example, like skills, training and staff shortages, personal issues. So whatever the things come under the organization, so there will be the part of project risk, as the supplier issues and organizational issue factors. We have to say like how many people are available, how many skilled people are available in that domain for which we are creating that project. Training we have to provide. For example, if any new team member has joined and you are not providing the proper training to that person, then there is no use. Like he or she will not be up, we can say, a good resource in your team, because you have not provided the training in correct way. So how you are expecting like he or she will provide their 100% output? Okay, so it is very important, like skills training, or maybe some team members are not available when there is any release, and also we have planned like 10 team members should be available, and only at that time 2 members are available. So definitely you will have to delay the release, or maybe according to the situation you have to decide like how many test cases I should execute for this release. So it is like a risk, because if you have to release on time and you are having less number of people available and you have to complete the release, then definitely you will miss, there's a chance of miss something. So they are saying it is kind of project risk, organization factor. Now, personal issues, maybe some members are not available because of personal issues. Political issues such as problems that stop testers communicating their needs and test result. So maybe in some kind of in some organizations, in a team, people are not communicating in proper way due to political issues. So this will come under this organizational factor. Now, failure by the team to follow up on information found in testing and reviews. So team is not following properly. This is also kind of lack of communication. So for example, if we have any kind of information and if we have to discuss on the defect, we have just raised it, or we are not communicating things in proper way, then it's a kind of organization factor, project risk. Now, improper attitude towards or expectations of testing, example, not appreciating the value of finding defects during testing. For example, you have found a very major bug in your testing, but someone is not appreciating you. So definitely, you will have a kind of low confidence on your side. Like, I am providing that much defects and I am doing my work in 100% way, but someone is not appreciating you. So you are not having the next time when you do the same work, you're not having that 100% confidence, or you are not you will not do that work in that much energy way. So it's a like of risk, because you have made your assumption like nobody is appreciating me, why I should do my work. So every time when you have to perform your work now, don't think like that. Just think like that you have to do your work. If someone is appreciating or not, it's their job, but you have to complete your job with 100%, providing 100% work. So it's like they are just providing this organizational factor, project risk, like how the situation can happen. Now, they are providing some more examples like technical issues. So till now we have learned the supplier issues. Second one could be the organizational issues, which is mainly related to the organization persons and the staff, everyone. And third one will be the technical issues, problems in defining the right requirements when we are developing the code. So definitely if requirement is not clear and it is not providing much information, then developer will develop the code with their own assumption, and you'll it will take more time. And maybe if it will come at the last stage of project, then definitely you have to again go through the starting stage and you have to correct it in everywhere. So if it's a lack of requirement, then definitely technical issues will come. Now, the extent that requirements can be met given existing project constraint. The extent that requirements can be met given existing project constraint, test environment not ready on time. Test environment is not ready on time and we have to perform the testing. So it's a kind of project risk under technical issue. Now, why this will come under this technical issues? Because test environment is a kind of technical thing. It should be ready. We are having the developers environment, and we have to perform testing on stage environment. And like a stage environment is not ready to perform the testing, then definitely it's a kind of risk in the delivery. Now, late data conversation, migration planning and development and testing data conversation, migration tool. So everything will come under this technical issues project risk only. For example, like you have to do the testing, but migration is not done properly. They have not made any plan, and they are just migrating code from one environment to another environment, and there is there may be some technical issue in that environment. So definitely it's a kind of migration planning risk. And after that, development and testing data conversation migration tools, they're not properly following what tool should be used for migrating the data, and they're just telling you to perform the testing. So it's a kind of risk. Maybe because in other time they will tell you like you have to perform the testing on this environment now. So there should be a proper plan, like in which environment I have to give my sign off whenever developers, or we can say the DevOps team is creating that environment, and they are just migrating the code. Then definitely you have to check properly everything, then only start the testing. Otherwise it's a kind of risk, because you are doing the things but there's no output. Now, low quality of the design, code, configuration data, test data, and test. So it's like if requirement is not defined properly, and design document is of low quality, it has not defined everything in detail way, then definitely it will impact the code. After that, the configuration data. After that, when we will perform the testing, we will also consider uh, less number of scenarios or test data to perform the testing. So everything will be, we can say, in combined way will impact the project risk. So it's a kind of technical issues. Now you have to remember here, like under project risk, what kind of issues can come. So there will be three things. First will be supplier issues, which we have seen. After that, we will be having the related to that person, or we can say that staff issue or the communication gap. Everything will come under the second thing, which we have learned, is organizational issues. And third thing is this technical issues. So these three kinds of categories will come under the project risk. Okay. So here they have just defined the example. So when I will share this PDF to you, just read it by your own, like how this level of risk will come. So for now, I'm just skipping it because it's a kind of example only they are providing for one scenario. For these third party supplier, if they are not providing the things properly, then what will happen? Okay. Now we are just reading this product risk. So previously we are not considering like how that risk is that much important, correct? But in terms of ISTQB, they have defined it in very well way what kind of risk can happen. So this is very important, because see, in your interview as well now, maybe you'll get this kind of question, like what you understand for the risk, and how you are handling those situations. So you just have to understand it in your own way, whatever I am explaining it to you, and you have to provide the answer accordingly. Okay. Now we are seeing this product risk. When planning and defining a test leader or tester using a risk-based testing approach will be managing product risk. Okay. When planning and defining test, this is very important. Like when we are making the planning, or when we are defining the test, a test leader or tester using a risk-based testing approach, we should not follow the testing in our way. We have to also check the risk associated with that test plan when we will start our testing. Okay. So potential failure areas in software are known as product risk, as they are a risk to the quality of the product. In other words, the potential of a defect occurring in the live environment is a product risk. So product risk is like related to the product when we will like complete everything. For example, we have delivered our product, and after that in the live environment we are getting a defect, then definitely it will be a very bad impression. And if it's a major bug, then definitely there will be no use of our testing, because we have to provide a quality software. That's why we are doing the testing. So there's a product risk. Now, example of product risk are failure prone software that delivered, the potential that a defect in the software or hardware could cause harm to an individual or company. For example, that kind of defect will come in the software or hardware that could cause harm to an individual or company. You have not tested it properly on all the environments are defined, and you have just delivered your code. So what will happen? Maybe it will cause harm to other people, or maybe you are having the multiple environments or multiple operating systems. You have to check that thing, but due to time constraints you have checked only those, only in the provided, or we can say we are having limited operating systems available, and we have to check it on multiple operating system. So when someone is using that application on their own operating system, and they are saying the wrong information is displaying there, and if that application is related to the medical, or we can say related to the health, and it is showing the wrong information, then definitely it will cause harm to people. That, yeah. So what we have to do, whenever we are closing the testing activities now, then we have to define everything, like whatever we have performed the testing, and on the environments which are not available, or the operating system which is not available, you have not considered it for testing. So that when someone is having someone needs to check like which operating system is supported by this application, then it should be logged somewhere, so that you can provide the information. Now, what is the other example they are saying for this product risk? So, poor software characteristic, example, functionality, security, reliability, usability, performance. You have not checked it all the things properly, then software characteristic will be poor. So you have made a software application and you have performed the testing, but you have not done it in proper way. You have not checked all the aspects. Then what will happen? Like application maybe will not respond for the 500 or 1000 users. You have checked only for the 100 people and it was working fine, but you have not checked for the large number of data. Then what will happen? When so many people will use that application, then this will not work properly. So they are saying this is a poor software characteristic. Now, poor data integrity and quality. Example, data migration issues, data conversation problems, data transport problems, violation of data standards. So you have used only a particular kind of data to perform the testing, but you have not checked all other things, like when data will be migrated, or there will be a different set of data, then how that application will perform. Then data transport, violation of data standards, you have not used in terms of security, how the data should work. So that all will definitely impact your application. So you have to check this data testing as well whenever you are testing any software that does not perform its intended functions. So we have defined it should you work like that, but it is not working properly, so it's a kind of product risk. So always remember, project risk will be the risk associated with when you are your project will be in development phase, and product risk will be mainly occur after your product is delivered. So they are saying like they have divided it accordingly in two parts, the project risk and the product risk. Now, as already stated, a risk-based approach to testing provides proactive opportunities to reduce the level of product risk stating, starting in the initial stages of the project. It involves the identification of product risk and how they are used to guide the test planning, specification, and execution. In a risk-based approach, the risk identifier. So what they are saying, if you will properly define the risk in the project level itself, now then definitely you will having the less number of chances to get any kind of product risk. Okay. So they're saying in a risk-based approach, the risk identified will determine the test techniques to be employed and or the extent of testing to be carried out. Example, the Motor Industry Software Reliability Association defines which test techniques should be used for each level of risk. The higher the risk, the higher the coverage required from test techniques. So what they're saying, like if you will, as per the test conditions or as per the test cases, if you will define the risk associated with that now, then definitely you will have a more quality project delivered. So prioritize testing in an attempt to find the critical defects as early as possible. We have to prioritize our work. We will find if we'll find the critical defects as early as possible, then definitely there will be a less number of chances when we finally deliver the product. Example, by identifying the areas most likely to have defects, the most complex, the testing can be focused on these areas. Will determine any non-test activities that could be employed to reduce risk. Example, to provide training to inexperienced designer. You have not provided the proper training to to the designers, and you're just expecting like they will do by their own, then it's not good idea. You have to provide proper training, and also it's a responsibility of designers, devs, tester, everyone in the team to provide the information. Like if they are not having the proper knowledge or proper training, just communicate, then only start your work. Then definitely it will not be a risk when you will do your work. So they are just defining what things we can follow to reduce that risk. Now, to ensure that the chance of a product failure is minimized, risk management activities provide a disciplined approach to assess continuously what can go wrong. Regular reviews of the existing and looking for new product risk should occur periodically throughout the life cycle. So here they are saying like we have to uh, how we can minimize the chances of product failure risk, or how we can minimize it to assess continuously what can go wrong. Regular reviews of the existing and looking for any new product risk should occur periodically throughout the life cycle. If there will be a chances we can get this kind of risk, then they have to review it properly, and they have to think like that if that can be type of risk can come when product is delivered, then they have to analyze it properly and make a proper plan. Now here they are just defining more points, like to determine what risks are important to deal with, probability into impact. This is the formula which we are using to check the level of risk. So just remember this as I explained. As the project progresses, owing to the mitigation activities, risk may reduce in importance or disappear altogether. So we have to check the probability and impact, both the things, multiply it, and we have to make for example multiple combinations of risk what can be happen after the product is delivered, to implement actions to deal with those risks. This is mitigating action. So we have to also check like if this kind of risk will come, then how we can deal with. We have defined the risk, but there should be also a plan how we will deal that particular risk. So this is the things. Now, testing supports the identification of new risk by continuously reviewing risk of the project deliverables throughout the life cycle. It may also help to determine what risks are important to reduce by setting priorities. It may lower uncertainty about risk by, for example, testing a component and verifying that it does not contain any defects. And lastly, by running specific tests, it may verify other strategies that deal with risks such as contingency plans. So we are just saying like for a particular test plan, if we are defining the risk also, and if we have already identified the defects, we are testing in a proper way. When we are delivering the product, we are just checking everything, and then we are delivering the product. And at that stage also, we are just defining the risk strategies in a proper way. So your product will be delivered in very smooth way. Testing is a risk control activity that provides feedback about the residual risk in the product by measuring the effectiveness of critical defect removal and by reviewing the effectiveness of contingency plans. So what testing is doing, testing is actually reducing the risk level, and they are it's a kind of control activity in which we have to provide our feedback in whatever time we have available, and whenever we are seeing any kind of major defect, where maybe your product is delivered and after that you got the major defect, then you should have to communicate it at that time. You should not have to hide that information. So in this way you will just control that risk activity by performing the proper testing. So this is the check of understanding, like what are the two type of risk that have to be considered in testing. So that we have already discussed. One is project risk and another one is the product risk. Now compare and contrast these two risk types, so that we have already learned project and product risk, what we have to consider, and after that how early in the life cycle can risk impact the testing approach. So it's obviously the we can say the starting stage which we have learned, like we should have to calculate the risk from the starting phase itself. Okay, what does MISRA determine when the level of risk is understood? So this was the example which we have learned, so you just read it again so that you will understood. Okay, so now this part is completed. We have to learn about now the test organization, like the risk part of in a broader way is completed, the project risk and product risk. Okay, so now we will have to learn about this test organization and independence. So independence, they are explaining here in the same way. So you just have to understood this diagram, because here they are just explaining it in theoretical way. So I'm just explaining this diagram, and that's what you have to remember. Okay, so now levels of independent testing will be from low to high, as we have seen it already in chapter 1. Like uh, it's a kind of psychology of testing. If you own will check your things, then definitely you will not find that much errors. If someone else will be checking it, then definitely they will find more errors in your work. So that's the kind of level of we can say independent testing or the psychology of testing. So how independent things are going, like first is the developer who write the code. Now we are checking the developer code, so the second stage will be independent testers coded to the development team, send it to the development team, And after that, we will be having the independent permanent test team, center of excellence within the organization. Now we have tested that. Now we are providing our things to the another team uh, in the same organization. After that, independent testers or test team provided by the operational business units. Now uh, there will be some other operational business unit, and they are having the independent testers or test team. So we are providing the code to check like how things are working. After that, specialist testers such as usability testers, security testers, or performance tester, they are a kind of specialist testers. So we are providing the code to check the security, usability, everything, performance is working fine or not. And after that, the last will be outsourced test team or testers, example, contractors or other organizations. So you will get a kind of question like, uh, in terms of independence, is what should be the best person, or what should be the best option which describe the more level of independence. So you should have two option like that. You should choose the option like that. The more out person is that now, who is having the more, we can say, independent of testing. For example, if you are having the question of just other organization, now just choose that option, because here the last one is that only, outsourced team or testers, example, contractors or other organization. So they are having the more, we can say, more level of independence. So just review this diagram one more time whenever I will share the slide it to you, and just try to solve the question. I will share that as well. And you have to choose the option very wisely, because in four options you have to choose it like who's having the more level of independence. So now this is that. Now they are just providing the benefits and drawbacks of this features of independent testing. So what could be the benefits? The tester sees other and different defects to the author. For example, developers has developed their code. Now as the testers, we are having a different approach, a different mindset to perform the testing. So definitely it's a kind of benefit. We will find the defects in a different way. Now tester is unbiased. So they are not biased like whatever developers are saying, and we will just assume it and we will just complete our testing. They are unbiased also, because they will do their testing in independent way, whatever the scenarios and whatever they plan. And apart from that as well, if they are having any other, we can say, other scenarios at runtime, then definitely they will test it. So they are a kind of unbiased. After that, the tester can see what has been built rather than what the developer thought had been built. So that's the same thing which I explained it to you, like tester will not check the things as per the developer mindset. They will check with their own way. Tester makes no assumption reading quality. Tester will not make any kind of assumption. So they will, regarding the quality, they will check everything, and after that they will give the sign off. Now what could be the drawbacks? Now isolation from development team. If treated as totally independent, which will mean the tester is totally dependent on the test basis to understand what it is the tester is testing, documentation that is rarely up to date. So one kind of drawback will be like, there will be isolation from the development team. because you are doing everything in your independent way. You are not checking the things as per the development team. So it's a kind of isolation. You will definitely not communicate everything in the proper way, and it's a kind of isolated from the development team. So because you are checking everything in your independent way, the tester may be seen as the bottleneck, as independent test execution is normally the last stage and affected by any delays earlier in the process. So tester may be seen as a bottleneck if every kind of problem, if any kind of problem or if any kind of issue will occur, then everyone will blame to you because you have tested it independently. Okay. Developers lose a sense of responsibility for quality, as it may be assumed that they need not to worry about errors because the independent test team will find them. So developers will definitely think like, why should I deliver the quality code? Because there is the testing team, independent testing team. They will check everything. Why I have to worry about my code? So that kind of things can happen. The fully independent view sets developers and testers on either side of an invisible fence. This can be a hindrance to communication that would, in normal circumstances, ensure common understanding and effective working. It can also mean that developers are seen to throw the software over the fence. So, developers will just like in a free way, they will just deliver the code. They will not understand about the quality, and they will just think like testers will do everything. If any kind of errors or issues will come, they will not take the responsibility or accountability. So it's a kind of drawback as well in the independence testing. Now, this is the check of understanding. What is independent testing? Why is independent testing more effective at finding errors than simply allowing the developer and author to test their own product? So, we have learned it like if someone is more independent, so definitely he or she will be find more errors rather than your if you check your own work. Now, name three benefits. So, these are the benefits like which we have learned here. So you just have to revise it. What kind of benefits can happen, like these 4 points. And after that, the next is which organization provides the lowest level of independence and which provides the highest. So in this diagram, lowest level of independence is the developer, or we can say who write the code, and highest number of highest level of independence is having outside of organization or the outsourced contractors. Okay, so just read it again, like developer is having lower number level of independence, and outsourced test team or testers, example contractors or other organizations, are having the high level of independence. Okay, in this way we have completed this independence testing topic. Now they are explaining the task of the tester, test leader, and tester. So just check it from here. Typical test leader task may include coordinating the development of the test strategy and plan with project managers and others. So uh, test lead will be what are the particular task of the test leader, how they have to think. So these are all the points they have explaining, like they have to coordinate with the development of the test strategy and plan with project managers and others. So they just have to coordinate everything with the project managers as per their plan. Whatever they have prepared, they just have to take the approval, and after that they have to proceed ahead. Now, writing or reviewing test strategies produced for the project and test policies produced for the organization. Now, we can say the testers have prepared the test cases or the test scenario. So it's the responsibility of test leader to review everything, and they have to check the test policies as well as per the organization. And after that, they have to give their sign off, and after that, testing team should start testing, contributing the testing perspective to the other project activities such as development, delivery schedules. So they have to check everything like what is the release date for this particular piece of code, and we can say how many testers should involve, what is the test plan. So everything test lead should review and check. Planning the development of the required test, which will include ensuring the development uses the correct understanding of the risk, selecting the required test approaches like test level, cycle, approach, objectives, and incident management planning, estimating the time and effort, and converting to the cost of testing and acquiring the right resources. So everything, who will check? Test lead will check everything, like everything is going in correct way or not, whatever the test level strategies we are defining, uh, is it correct to give it to testing team to perform the testing. So everything will be checked by the test lead. And also they have to remember, like, are we using the right resources? For example, if any new team member has joined and they are just providing the task to them to perform the testing, and they are not having the proper training, then there will be no use. So they have to firstly provide the proper training, then only give the particular task to the team members. So this is a kind of approach test lead should be review. Managing the specification, preparation, implementation, and execution of tests, including the monitoring and control of all the specification and execution. So they have to check this as well, like managing the specification, preparation, implementation, execution of test, everything. For example, a particular report is they have to prepare after the test execution complete. So all these tasks will do by the test leader. Now, taking the required action, if they have defined any kind of risk in the planning document, or if any weird situation will occur, then how things will go in control. So that test lead has to be defined. Now, they have to check test result and progress, status report, and any action necessary to compensate for problems or delays. Ensuring that adequate configuration management of testware is in place and that the testware is fully traceable. Example, there is a hierarchical relationship established between the requirement and the detailed specification document. So they have to check, like, whatever testing activities we are performing in that particular testware. So they have to check, like, the hierarchical relationship between whatever requirements we have defined. As per that, uh, the test cases should be matched, so that we there should be a smooth testing. So they have to check these test life cycle as well, like, for example, if you have defined for a particular requirement 5 number of test cases, so it's the responsibility of test leader to check whether these 5 test cases are relevant to that requirement. It's not like they will just review the test cases and they will assign it to test team to perform the execution. They have to check the relevancy also. Now, putting in place suitable metrics for measuring test progress and evaluating the quality of the testing delivered and the product. So they have to also provide a suitable metrics or a kind of report to the progress whatever testing team is doing, agreeing what should be automated to what degree, and how ensuring it is implemented as planned. As we have planned, according to that whether we are automating the things properly or not, or maybe some scenarios we cannot automate. So it's a responsibility of test leader to check. Where required, selecting tools to support testing and ensuring any tool training requirement are met. So it's a kind of responsibility of test lead, like whatever tools we are using, whether it is supporting or not, and it is working properly for all the test team members. So they have to check the proper tools accordingly, so that the proper outcome can come. Agreeing the structure and implementation of the test environment, scheduling all testing activity they have to schedule for all the test team members. They have to just check every member is working correctly or not. So this is the responsibility of test lead. At the end of the project, writing a test summary report based on the information gathered during testing. So at the end of testing or at the end of project, they have to provide the test summary report to all the stakeholders and project managers, like this is a kind of testing we have done in this phase. So all these responsibilities are included in the test lead plate. They have to just manage everything, the whole testing team. Okay. Now we have to see the task of testers. Okay, so the other role covered by the syllabus is that of the tester, also known as a test analyst or test executor. The tasks typically undertaken by a tester may include reviewing and contributing to the development of the test plan. Now, whatever test lead has prepared, we have to check, like whether that test plan is correct or not. We have to also provide our suggestion as per the tester, like everything should be correct. After that, analyzing, reviewing, and accessing user requirements, specification, and models for testability. So, see, test lead will just prepare the plan, and they will assign the responsibilities to you. But you have to check, like whatever they have provided, you have to review, analyze the things, and accordingly, you have to communicate everything, and you have to start the testing. Creating test specification from the test basis. So it's like creating the test specification is like test cases from the test basis. So test basis will be the requirement document. Okay. Now, setting up test environment. In some organizations, the setting up and management of the test environment could be centrally controlled. In this situation, a tester would directly liaise with the environment management to ensure that the test environment is delivered on time and to specification. So it is not the responsibility of tester to, we can say, prepare, we can say he has to manage the test environment. But maybe in some organization, it's a controlled center environment. You just have to check whether that environment is ready or not to perform the testing. But in some organizations, it is the responsibility of tester to set the test environment. So as per their knowledge, they are providing the responsibilities. So they are just explaining, like setting up the test environment in other organization, maybe it's a responsibility of tester, but in some organization, it's not the responsibility of tester. There's already a central control environment. We just have to check that environment is working or not before starting the test execution. Now, preparing and acquiring, copying, creating test data. So everything, whatever we have to do to execute the test cases, we are preparing the test cases, then we have to perform the execution. We have to prepare the test data. These all activities will come under the tester plate. Now, implementing test on all test level, executing, logging the test, and logging the defects as well is the responsibility of tester. Evaluating the result and documenting the deviations from expected result as defects. Using test administration or management and test monitoring tools as required. So, see, maybe test lead will provide you have to perform the testing on this tool, but maybe in at a particular time that tool is not working, so it's the responsibility of you as well to check and monitor whether that tool is providing the like we can say the specified outcome, or we have to check the tool is working properly or not and every on our machines. So it is the responsibility automating the test if we can say the test lead has assigned to automate some test cases, then you have to check like what tool you should use, where required running the test and measuring the performance of components and systems is applicable. Now reviewing tests developed by the other tester, they have to uh, for example 4 testers are working in a team, so it's not like they will check their own test cases. Uh, Actually, it's a kind of peer review. So whenever you have developed your test cases now, if you will give it to your peer members, then maybe they will we can say find the faults or errors in your test cases, or maybe they will provide you the more functional specifications for that particular scenario. So it's good if you will provide the test cases to review to your peer members uh, before giving it to the test leader or the management. So there will be a good thing. Now, if specialist testers are not available, then additional resources could be used at different test levels. If specialist testers will not be available, for example, we have to check the performance testing, security testing. If someone is not having that knowledge, then definitely we have to hire more testers in that case. So they are saying for component and integration testing, any additional roles would typically be filled by someone from a development background. For unit testing or integration testing, if testers are not having knowledge to check the modules properly, then definitely it's a responsibility of some other tester who is having more technical background or more development background. For system and user acceptance testing, any additional roles would typically be filled by someone from a business or user background. So, user acceptance testing is like we have to check as per the requirement, particular product or project is built or not. So, for that, uh, definitely, additional roles will be a stakeholder or the business person who's having more knowledge on the business. Now, system operator, sometime known as production support, would be responsible for operational acceptance testing. So they are just defining the roles here who can perform this task in a better way. Obviously who's having the more knowledge on that task, then definitely we have to provide the task to them, not everything to the testers. Now, check of understanding, like what other names are given to the test leader role. So you just have to revise it, what we can call the test leader, what other names can we provide, and after that detail 5 possible tasks of test leader, so that we have already learned. 5 possible tasks of tester, that we have already learned. Describe the differences between a test leader role and a test leader task. So test leader role is like we can say uh, when you revise that slide now, then definitely you will find what is the test leader role, and after that the test leader task. So task we have already discussed, like they have to prepare the report, they have to manage everything, they have to check the test strategy, test level, everything they have to check. And role is like we can say it's a kind of responsibility, the main task he or she has to just do the things in a smoother way. So this is a kind of test leader task. So from this you will get, might be a question, it's not necessary you might get the question, but maybe you will get the question like that, the task of a test leader and the tester. So you just have to revise it, the task, the key bullet points which I explained it to you, the test leader task and the tester task, then only you can provide the differentiation. Okay, so now we'll be reading this test approaches or test strategies. Now we have to check this test approaches or test strategies. A test approach is is the implementation of a test strategy on a particular project. The test approach defines how testing will be implemented. A test approach can reflect testing for a whole organization, a program of work, or an individual project. So test approaches or test strategies, what can be that? So uh, hmm. Developed early in the life cycle, which is known as preventive. In this approach, the test design process is initiated as early as possible in the life cycle to stop defects being built into the final solution. So first test strategy they are saying is, it's a kind of preventive strategy in which we will start this approach at the initial stage, at the design process itself, as early as possible in the software development life cycle, so that we can stop the defects being built into the final solution, left until just before the start of the test execution, which is known as the reactive. So second one strategy will be reactive. First is this preventive and second is reactive. This is where testing is the last development stage and is not started until after design and coding has been implemented. Sometimes it is identified as a waterfall approach. That is, all developer stages are sequential, the next not starting until the previous one has nearly finished. So it's the we can say we are having the different models. For example, we have learned the V model, okay, then we have learned the waterfall model, then iterative model. So it's not like we have to check the things and accordingly we have to follow the approach, what approach should be followed. Now
Okay.
after that they are just saying this is where the testing is the last development stage and is not started until after design and coding. Yeah, so that what I was explaining is like it's the approach we have to decide what approach we should follow. For example, we have to take the waterfall model or the V model or the iterative model. So it's the approach we should be deciding. There are many approaches or strategies that can be employed. All will depend on the context within which the test team is working and may consider risk, hazards, and safety, available resources and skills, the technology, nature of the system, test objective and regulations, and may include analytical approach, model based approach, methodological approach, standard compliant, process compliant. So this is a kind of approaches they are just explaining which we can take as per the situation. Okay, so now we have to see this test strategies or approaches. So first one, they are saying it is an analytical approach, such as risk-based testing, where testing is directed to areas of great risk. So if you'll get a question like, what is the approach which we have to follow in terms of, we can say, greatest risk. So the name will be the analytical approach. Okay, second is model based approach, such as stochastic testing using statistical information about failure rates, such as reliability growth models, or usage such as operational profile. So if you will get the question like which approach should be we have to follow as per the statistical information. So you have to provide the answer as model based approach. Okay. For analytical, so in your notes, if you are making somewhere, just highlight this, like for the greatest risk based we are using the analytical approach. Then second, for the statistical information we are using this model based approach. Third one is methodological approaches such as failure based, including error guessing and failure attacks. Checklist based and quality characteristic based. So third one is methodical approach. This will be followed as per the error guessing and fault attacks. So if you have to check the failure based thing, then definitely you will follow this methodical approach. After that, we'll be having the standard compliant approach specified by industry specific standards such as the railway signaling standards or the MISRA, which defines how to design, build, and test reliable software mo- uh, for the motor industry. So for every industry we'll be having a standard compliant. For example, if there's a food industry, they are having a specified standard. If there's a healthcare industry, then they are having a particular standard to build up the software or project or application. You have to follow these kind of standards. For example, um we can say we have to prepare an application related to the traveling, which includes the flight booking. So they have to follow a particular standard to make the particular application. So as per that, the approach should be the standard compliant approach. As per the domain, you have to follow the industry specific standard. After that, we'll be having this dynamic and heuristic approach, such as exploratory testing, where testing is more reactive to events than pre planned, and where execution and evaluation are concurrent tasks. So,
I think you missed process
process
compliant
compliant, no?
approach.
Yeah, yeah,
Yeah.
I will explain it after it. Dynamic
Okay, okay. Okay,
heuristic.
no problem.
Okay, so exploratory testing is like we are just checking the things uh, on the basis of our exploration. We are not having the more time to perform testing, so we are just exploring the project or product, whatever it is built. So this is a kind of exploratory testing, and it will come under this dynamic approach. So standard compliant is like we are checking as per the industry standard. We have to follow the approach. And exploratory testing, or where the un kind of situation will come, so we have to follow this dynamic kind of approach. We have to adopt the things. If time is not available, we just have to check it in a quick way, or we are having the less number of time and we have to check everything in one go, then we have to perform the testing in exploratory way. We are not having the time to prepare any document. So in that way we have to follow the dynamic approach. Okay. Now another one is this process compliant, which adhere to the process developed for use with the various agile methodologies or traditional waterfall approaches. Now, whatever the process we are following, for example, whether we have to choose this agile methodology or the waterfall approach for the project, so for that, we are just using this process compliant, as the name suggests, what process we have to follow, agile or waterfall. Now, another one is consultative approach, such as those where test coverage is driven primarily by the advice and guidance of technology and or business domain experts outside or within the test team. Now, consultative is like we are just consulting the things with outside business, or we can say who is having the more information regarding that business. We are just consulting the things from them firstly, then we are just starting the project. So it's a kind of consultative approach. And after that, last one is this regression averse approach, such as those that include reuse of existing test material, extensive automation of functional regression test, and standard test suite. So regression is like we have already prepared everything, and after that, regression versus like we again want to use same thing. So for that we are just following this regression averse approach. So to revise, first will be the analytical approach. In analytical approach, just provide, if it's a kind of risk based testing, then you have to follow this analytical approach. If it's a kind of statistical information related testing, then you have to follow this model based approach. Now, if you have to perform the testing related to the failure, for example guessing or fault attack, then you have to follow this methodical approach. After that, we'll be having this standard compliant. Standard compliant means if you have to perform the testing as terms of industry standard, then you will follow this standard compliant. Then we'll be having this process compliant. If you have to follow the approach as per the process, whether it is agile or waterfall, then you will follow this process compliant. After that, we'll be having this dynamic approach, in which we have to check if we are not having much time, and then we'll be just performing the testing on the basis of exploratory, and we have to follow this testing dynamic approach. And after that, we'll be having the consultative. If we are not having the knowledge or information about the software project or product, then definitely we will consult it with someone which is related to that business or domain. Then it's a kind of consultative approach. And after that, last one is regression averse, in which we will be just reusing the same component or same testing which we have performed previously. Then we will follow this regression approach. Now, these are the factors which should be considered when defining the strategy or approach. First one is risk of failure of the project, hazards to the product, and risk of the product failure to humans, the environment, and the company. Example, the cost failure would be too high. Cost of failure would be too high. So they are just saying like when we are defining these strategies now, we have to check these factors. For example, first one is that risk. Second one is that skills and experience of the people in the proposed techniques, tools, and methods. There is no point in implementing a sophisticated component level technique driven approach or strategy when the only resources available are business users with no technical grounding. So you have prepared the document, or you have prepared the everything in very technical way, but the person who is just checking it, for example, it is purely from the business background, who don't know what is the technical architectural diagram, and you are just explaining it, so there is no use. You first have to check whether that person is skilled or experienced. Then you have to provide your information, and then you have to decide the approach. Now, third one is the objective of the testing endeavor and the mission of the testing team. Example, if the objective is to find only the most serious defect, so there should be a particular objective as well. If you have to only check the most serious defect, then definitely your approach should be like that. You will not you will not consider the model based approach to perform the risk based testing, because your objective is to find the most serious defect. Then definitely you will consider the another approach. Now, regulatory aspects such as external and internal regulation for the development process. Example, the railway signaling standard that enforce a given level of test quality. Now, before starting the testing of particular standard industry standard application, you should be firstly understand what are the industry level standard for the particular application, then only you should start preparing the scenarios. So you first have to understand the regulatory aspect, then you should decide the approach. The nature of the product and the business example, a different approach is required for testing mobile phone coverage than for testing an online banking solution. So, for if you are testing any online banking operation solution, then definitely you have to check more on the security aspects. Uh, Rather than when you are testing a mobile phone coverage application, then there should be a different approach. So this is in this you just have to remember the approaches, the name of approaches, and at what condition which approach should be used. And second one is this these factors. So this is a kind of theoretical thing, like what factors are impacting, and what according to which factor which strategy should be used. So just read it and just try to understand it as per the factors which approach we should have to adopt. Now, check of understanding, name and explain 5 approaches to the development of the test approach or test strategy. So you have to remember these names by heart, like what should be the names of these strategies. Now, name one of the standards referred to that dictate the test approach. So, standard based approach, you have to remember the name. What was the name? It was industry standard approach. So I think it was a standard compliant. Yeah. So this is the standard
Yeah.
compliant approach. Okay.
Mhm.
Now, can discretion be used when defining a test approach? And if so, what can influence the decision as to which way to approach testing? So, this kind of question will be just for understanding. So, in this, you will get a kind of optional questions, not whole. We can say we have to explain it everything. So, just read it one more time when you'll get time. Just remember these names so that you can choose the right question, right answer. Okay.
Mhm.
Now, this is the test planning. So, hmm. Test planning and estimation. So here, this is the figure shows where test level test plans fit into V model. It shows how a test plan exists for each test level, and they will usually refer to the master test plan. Okay, so it's just a diagram which you do not have to remember right now. In this part, you just have to remember the test plan elements in terms of ISTQB. Remember, when you find it on Google, you are having the different 16 test plan component, but or the element, but in terms of ISTQB the names are totally different. So you just have to remember those 16 elements of test plan by heart. And each we can say each member is each element, or what should be the descriptive form for that element. So you have to remember, you will definitely get a question, you can say 2 to 3 questions related to the test plan elements. Okay.
Okay.
So you can just read it when you'll get time, like what are the factors influencing the test planning process. So this is the master or project test plan, and uh, here they are just defining the factors like risk, constraint, resources, criticality, test policy, scope of testing, test objective, testability. And these are the component test plan, integration test plan, system test plan, and acceptance test plan. So remember, in the V model, we have left arm and right arm, and as per the each testing level, we have to define a particular test strategy or test plan. So they are just define it in a single diagram, like for the component test plan, integration test plan, system and acceptance test plan, what factors they have to consider, and after considering these factors, what should be the master or project test plan. Okay.
Mhm.
Now, these are the test plan section here. They have just, I think here they have defined those 16 elements. Okay. So now you have to just remember these test plan sections. First is this test plan identifier, a unique identifying references such as document reference XYZ. So it's like the test plan identifier who is preparing that particular document. For example, a unique identifying reference such as document reference this. So you have to just define a 1 minute, I'm getting chat. So, in the test plan section, first will be test plan identifier, a unique identifying reference such as document reference number. So, where we will be defining the document reference number, it will be test plan identifier. Now, it's a kind of version. When we are preparing the document now, we have to define a particular version for that particular document. So that version is defining under this test plan identifier section. After that, we'll be having the introduction. So introduction is like a brief introduction to the document and the project for which it has been produced. A test item is a software item, is the object of testing. So this is the test item. Okay. Introduction is like where we are just defining this brief introduction of the document as the name suggests. Test item is the test item is a software item that is the object of testing. A software item is one or more items of source code, object code, job control code, or control data. So test item can be anything. It may be a object code, job control code, control data. This section should contain any documentation references, example, design document. Okay. So test item can be anything. Maybe it can be design document, maybe it can be technical design document, or maybe it's a kind of technical requirement document. So anything can be comes under this test item. Now, fourth one is features to be tested. A feature is a distinguishing characteristic of a software item. When you will define a kind of software item, example, performance, portability, or functionality, then definitely, as per the test item, you have to define what kind of features we should consider for that particular test item. So you have to define, for example, performance, or only the functionality, or only the UI, or only the portability, security, maintainability, what kind of testing you have to perform for the test item. That you will define under this section, the features to be tested. Fifth one will be features not to be tested. You have to define this one as well, like what features we should not consider. Identify all software features and significant combination and state the reason for not including them. For example, you are delivering the first phase of software application, and you know you have to just deliver these things. You have to mainly focus on the functionality first, and in the second phase you will consider the security and other terms. So in features to be tested in the phase one document, you will define these features, and in the what features should not to be tested, you will define the reason as well. Like for example, we will consider in phase 2. Okay. Now uh, sixth one will be approach. Details the overall approach to testing. This could include a detailed process definition, or could refer to other documentation where that detail is documented. That is a test strategy. So if you will get a question where we will be defining the test strategy, then the answer will be approach section. Okay.
Okay.
Now, item pass or fail criteria used to determine whether a software item has passed or failed its test. So, pass or fail criteria is like you have to define whether we will consider this test item is pass, and whether where we will consider the test item is fail. Okay. Now, eighth one is suspension and resumption requirements. Suspension requirements define criteria for stopping part or all of the testing activity resumption requirements specify the requirements to resume testing. Suspension and resumption is like, for example, whether when all the testing activities are completed, or maybe some kind of application is failing. If something is failing, then when you should suspend it, and when you should resume it. So these both conditions you have to define under this suspension and resumption requirements. Ninth one is test deliverable. The documents that testing will deliverable, example from IEEE 829 documents such as test plan for each test level, test specification, design, case and procedure, and test summary reports. Hmm. So under test deliverables, we have to define every document, okay? Test plan document for each test level, and we can say test specification, design, case and procedure document, and test summary report. So if you will get a question where we will be defining the test summary report, so the answer will be test deliverable, okay?
Okay.
Now, testing tasks, all tasks for planning and executing the testing, including the inter-task dependencies. So all these things you will define under the testing tasks, like who will do the test task, and executing the testing, and also if any kind of dependency related to the testing task. Now, environmental needs, defi- uh, definition of all environment requirements such as hardware, software, PCs, desk, stationery, everything which is related to the environment, you have to define under the environmental needs. For example, the particular operating system, or whether it will be supported on web only or on mobile also. So all these things you have to define under this environmental needs. After that, we'll be having the responsibilities, identifies the roles and tasks to be used in the test project and who will own them. So you have defined every task. Now who will responsible for every thing. So for example, testers, developers. So you have to define everyone's name in under this responsibility section, like who will do what. Now after, we'll be having this staffing and training needs, identifies any actual staffing requirements and any specific skills and training requirements. Example, if you have to automate the things, then who will be the main responsible person, and if you have to provide the training to other team members as well, then you will define under this staffing and training needs. After this, we'll be having schedule. So under this schedule section, you will define document delivery dates and key milestones. So you have defined everything. Now you have to provide the estimated delivery date for each and everything. So you will define under this schedule as the name suggests. Now, 15th is risk and contingencies, high level project risk and assumption, and a contingency plan for each risk. If any kind of risk will come, then what should be the plan we have to follow? This will define under this risk and contingencies. And after this, the last one is approval, identifies all approvals of the document, their titles, and the date of signature. So, when that particular test plan document is prepared, we have to take the approval as well. So, we will define every approval person name, and they have to sign that document. They then only will be proceeding ahead. Like that's its approval document, and after that we can proceed ahead for the next phase.
Mhm.
So these are the 16 elements which you have to remember, and as well as the details, like in which element what we are performing. So you will definitely get a question from this. Okay.
Mm.
Now, okay, so here they are just explaining the same thing in detailed way. This is the test planning activities.
What is the space dirt?
They have just defined it like the acronym for this IEEE
Okay.
standard. Space dirt is a like of as per the IEEE 829 test plan. They are just defining this, the acronym for this space dirt.
So it is scope, people, approach,
Yeah,
criteria,
criteria, environment needs, deliverable.
templates,
Yeah,
identifier, risk and contingency. Okay.
test task and
Space
schedule.
dirt.
So in terms of that, you can just read it. What's the name of this? But they have just provide a useful revision so that you can just revise it is with this space dirt. But actually now, Swati, you just have to
Yeah.
remember these names by heart only because
Uh-huh.
they have defined here like scope, people, approach, criteria, environment need, deliverable, and all these things. But actually, you have to remember these 16 elements, okay? Because you will get the name and you have to choose the option.
Mm-hmm.
Now, this is the test planning activities. During test planning, various activities for an entire system or a part of a system have to be undertaken by those working on the plan. They include working with the project manager and subject matter experts to determine the scope and the risk that needs to be tested. As well, identifying and agreeing the objectives of the testing, be they time, quality, or cost focused, or in fact maybe a mixture of all three. The objectives will enable the test project to know when it has finished. So these are the test planning activities. We have already seen the elements. Now they are just explaining it like what things we have to define there. For example, the risk, or we can say the quality, the time, everything we have to define under the test plan document. Now, putting together the overall approach of testing, ensuring that the test level and entry and exit criteria and define. This is very important. We should be defining the entry and exit criteria, uh, liaising with the project manager and making sure that the testing activities have been included within the software life cycle activities such as design, development, implementation. Everything we have to define here. Now, uh, this is very important. Finding and assigning resources for the different activities that have been defined. We have to also define this resources as well. Building a plan in proper way. We have to define who will take the test analyst and design activities. Working with the project to decide what needs to be tested, what roles are involved. Everything we have to define under here. Now you have to remember this thing, this key point. This is like exit criteria. So deciding how the test result will be evaluated and defining when to stop testing. This is the exit criteria. Okay. So
Mm-hmm.
when we will be do define where we will be defining these things like how the test results will be evaluated and defining when to stop testing. Defining when to stop testing, where we will be defining under the exit criteria. Just remember this point, maybe you'll get the question. Okay. Now deciding what the documentation for the test project will be, example, which plan, how the test cases will be documented, etc. Defining the management information, including the metrics required and putting in place to process, to monitor and control test preparation and execution, defect resolution, risk issues. So everything you have to, it's not like you have prepared the test plan document. and you cannot revise it. You can define the many version of the test plan document, and you can just revise it as per if you're getting more risk, then definitely you have to define your document. If the requirement gets changed, then you have to again update your document. So it's a kind of every information you have to provide there. Monitor and control test preparation as well. Now, ensuring that the test documentation generates repeatable test assets, test cases. So these things will be defined. Now, what is the entry criteria and exit criteria? Entry criteria is used to determine when a given test activity can start. This could include the beginning of a level of testing, when test design and or when test execution is ready to start. So remember, in entry criteria we will be starting our testing part. Okay, when testing can be begin, we will be defined under the entry criteria. Example of some typical entry criteria to test execution may include test environment available and ready for use, test tools installed in the environment are ready for use, testable code is available, all test data is available and correct, all design activities has completed. So uh, test design activities are completed, test data is available, environment is ready to test, everything that we will be checking under the entry criteria. Now, exit criteria is like these: all test plan have been run, after that a certain level of requirement coverage has been achieved, no high priority or severe defects are left outstanding, high risk areas have been fully tested, cost, the schedule have been achieved, everything is completed under or everything is completed or not, we are defining under this exit criteria. uh, Maybe you'll get a question: a certain level of requirement coverage has been achieved, where we are checking it, or no high priority severe defects are left out understanding, outstanding defects are remaining, where we are checking it, so we are checking it under the exit criteria. So you just have to remember these bullet points for entry criteria and exit criteria.